Welcome back. In my last video I've shown you how to write a driver for the GPIOs of a Raspberry Pi, and today we will be playing around with GPIOs too, but today we will write a driver for this text LCD display. So this is a display with a HD44780 control IC, and it's very common used, and you can see part of the pinout here. So we have 8 data bits, a switch to decide whether we want to send data or instructions, and an enable button. So if we have set our data bits here, if we set our toggle switch here to data or instruction, and then if we toggle the enable pin, the data will be latched, or the command will be latched. And we have 8 bits here, but this is a really wide bus, and in some applications you don't have so much GPIOs, so you can decide if you want to use this display in an 8-bit or a 4-bit data mode. But to keep it more simple, I have decided to use the full 8-bit interface. But before we can send data, here we have to initialize the display. So let me set this pin here to instructions, and by setting bit 4 and 5, I tell the display, hey, I want to use the 8-bit interface. Okay, so now let me press enable, and we see nothing has changed. And now I will send a second command to initialize the cursor, to set the cursor blinking, and to turn the display on. Okay, so now we can see here we have our cursor and it's blinking. And now we can send some data. For this I have to pull this switch to data. And now I can write some data out. Great. And if I want to clear everything from the display, I can do so by going back to instructions and send a 1 here, and this will clear my display. Okay, this was a very short introduction about how to use the HD44780 control IC to control a LCD display. If you want to see more details, I will put a video in the description, a video from a YouTuber called 8-Bit Guy, and from him I got the idea of assembling an LCD display and the switches on this thing here. But today we want to write a Linux driver to control such an LCD display. And for this reason, I've prepared something here. Okay, here I have my Pi, and I've hooked up the LCD display to my Raspberry Pi, and today we want to create a driver for it. So just let me make this a little bit smaller. Okay, so now I'm back on my Raspberry Pi here. So as you can see here are our projects and drivers, and what I've done here is I've just copied the source code from the GPIO driver and gave it the name 5 LCD display. Let me cd into it, and here I've created the file LCD driver, and I've already done some modifications to it, but now let's check it out here. And I have changed the make file so it will build the LCD driver.c and not the GPIO driver. Okay, so let me open up this file. So as you can see here, I've changed the description, I've changed the name. Here I have created a variable for our LCD buffer, as it is a 16 char long display. I need a buffer of 70 chars because the last char is 0 character. Here I have defined a list of GPIOs I'm using, So I've hooked up GPIO3 to the enable pin, GPIO2 to the register select pin, and so on. Down here I have defined the enable pin is GPIO0 and the register select pin is GPIO1. Okay, now this is just the same like from the GPIO driver. I have only removed the part where we write to the GPIO. Okay, down here we have the open and close method. I haven't made any changes here. I only have deleted the read, the driver read function, because we just want to write to the driver. Okay, and here in our init function, I've made some little changes. So here I have defined an array with all the names of the pin I want to use. Okay. The rest is just the same. Here we are creating the device number, the device class, and the device file. We will register it. And down here comes something new. I've added the initialization of the GPIOs. So because I have 10 GPIOs, I'm using a for loop, and I will request every GPIO, and if the function returns something greater than 0, I've got an error, and I will go to GPIO init error, and down here I set all the pins to outputs, and if an error occurs here, I will go to GPIO direction error, and if an error occurs, if a GPIO error occurs, for example, after the 5th GPIO pin, an error occurs, okay, then it will free the 4 GPIOs it has already initialized, and if a GPIO direction error occurs, it will set our iteration variable to 9, and it will free all GPIOs we have requested before. And of course, if I request something, I have to free it in the exit function. So here, what I'm doing here is I clear all the GPIOs I've requested, and before I clear it, I set the value to 0. Okay, so now let's add some code to write to the LCD display. Okay, so first I need a function to generate a path on the enable pin. I will call the function LCD enable. And all it does is it will set the enable GPIO to 1. Then it will wait a little while. I'm choosing 5 milliseconds here. You can use a shorter time, but for our purposes it will be okay, and then I will just set the GPIO to 0 again. Okay, so the next thing is we need a function to send bytes to the to our 8-bit interface here. Okay, I will create a new function here. it with data plus data set I will call the function LCD send byte. Okay. As an argument, I'm using a char here. Here I declare an iteration variable. Okay, and what I'm doing here, okay, I'm just setting all the data bits. Okay, and after setting the data bits, I will toggle the enable pin to send the byte, and I will leave 5. Okay, and I will wait for 5 seconds. So and now, as we saw on my 3D printed button LCD thing, we can send data or instructions. So let's create a function to send data and instructions. Okay, I will call the method LCD command. Okay, and it will have a uint8 variable. Okay, and all we have to do is we have to set the value of the register select pin, and then we have to call the LCD send byte function. So register select, I will set register select to 0, and 0 means RS2 instruction, and then I can just send LCD send byte. Okay, and the cool thing for our next function for sending data to the LCD, we can just use the same function. All we have to do is we have to set a register select to data, and we have to give the function a different name. Let's say LCD data. Okay. So now, here in our function, in our write function, all we do is we calculate the amount of data to copy by using by searching for the minimum between the size of our LCD buffer, which is 17, and the amounts of bytes we are passing to this function. Down here we copy from the user buffer into our LED buffer, and now we can set the display. Okay. Well, the first thing we are going to do is we will clear the display, and as I showed you at the start, all we have to do is send the LCD command 1 here, Okay, and then I will git copy. I will print the data out on the display. Okay, that's it. So much for the write method. Now the last thing we have to do is to initialize our display. But this is just sending two commands here. Okay. So the first thing we will do is we will send the command 30 hexadecimal for a data interface. Okay, then we will send the command F, and this will turn display on, turn cursor on, set cursor blinking. Okay, and now I will just clear the display again, just in case there's some stuff on display. And yeah, let's create a little text here. Hello world. And I will print out this text here. And that should be it. Okay, my Wi-Fi to my Raspberry Pi is a little bit bad today. Okay, now it's back. And now let's just check if we're cleaning everything up correctly here. Yeah. Here we are unsetting the pin, and I will add a clear command here. Clear the display at the end. Okay, and now let's try to compile the whole thing. Okay, I've got some errors here. OCD enable. Okay, easy. Enable. Okay. So okay, let's try it again. Okay, redefinition. Okay, looks like I have already defined the text variable. Here we go. Okay, it seems I will enable. Okay. Let's try to compile it again. Okay. GPO set value. Expected declaration specifier or before numeric constant. Error. Enable pin. Okay, I'm not quite sure why I have this problem here. GPIO is spelled correct. Okay, for simplicity reasons, let's just type GPIO 0 here. Let's decompile it again. This is strange. In line 85. Ah, okay. Strange. Okay, but now we were able to build our module. Now let's test it. Hopefully it will work. Yay! And now we can see here Hello World is printed out. And now if I look into our device folder, we have a LCD device file here. And now let me change the permissions, the read and write permissions. So everybody can write to it. Okay, hopefully this isn't longer than 60 chars. No, it isn't. Cool, now we can write stuff to it. Cool, isn't it? And if we want to upload it, or we type sudo rm LCD driver. Okay, and then the display will be cleared. So that's how to write a simple LCD text display driver. I will take my code and hold it up to GitHub so you can look at it. Thanks for watching, and I hope I will see you in my next video.